Hello guys, once again welcome to my YouTube channel, and I hope you've already subscribed to the channel. If you've not subscribed to the channel, make sure you hit that subscription button, make sure you like my videos and comment your thoughts, and I promise there are lots of exciting videos going to come soon. Alright, so for today we are going to do something interesting. So um, we'll be dealing with flood analysis. So we'll be learning how to perform flood analysis in ArcMap. So first of all, there are certain data you need to get before you can perform that flood analysis. So the first data you need is your DEM, that is a digital elevation model. So you need a DEM that shows you the elevation of the topography um, you are trying to work with, and then you also need um, a land use land cover information to perform the flood analysis. So this an example of what a DEM looks like, the digital elevation model. You can change the color if you do not prefer this, and you can do whatever you want to do. So you could see you can just click on this and color ramp, and then choose a color to make this um, more interactive. So we could choose this and click on OK, and you see it's going to give you this. Alright, and this is also our classification image. So this is supervised classification. So these so based on the classes we have here, this one classify, which is not part. So these are the built-up areas or the settlements, and then we have the vegetation, that is the green side. We have the water bodies inside, and then we have the bare land inside. So this is a supervised classification, and we are going to overlay it with the DAM, and then we'll also perform some reclassification and get a very nice flood risk analysis. All right, so to start, so there's another way you can open this DEM in ArcMap. So we need to open our ArcScene. So ArcScene is just meant to see something in a 3D form, and that is a 3 dimension. So you can see the length, the breadth, and then the height of the image. Yeah, so that is what ArcScene is all about. So to do that, we can just open ArcScene and then load your image. So you need to know where your image is, just the same interface as the ArcMap. So you need to load your image. So I've already loaded mine here. So you could see once you load the image, you're going to get something flat or something like this. Then we need to come here, open our properties. Then you can choose anything you want here, but we need to come to the base height. So we come to the base height, and then we select no floating on surface, and you can choose any height or offset you want based on everything. Then you can click on apply, click on OK. So you realize the image has disappeared. So you need to come click on this layer, right click on it, scene properties, and come to calculate from extent. So it's going to generate it for you. Then you leave everything and just click on apply and OK. So as you can see, there's our 3D model of our 3D elevation model. So we can adjust the height, come to properties, and you come to the base and then the height. Then we can select, let's say, um, 2. Let's try 2 and see what happens. So as you can see, the height has increased. So based on what we have here, if we click on 3, we see it's going to increase. So let's just do without 2 for now. And okay. So you can see this is the topography or the elevation of this image. So if you're worried about how to get this image, you can go to the USGS site, that is the United States Geological Survey, and then you get all this data there. And probably you want to make it more interactive by adding a color ramp. So I usually prefer this so you can see the red, yellow, green. Yeah. So when we picture this in 3D, this is what we have. So the red ones simply identify a very low or a very low height. So you can see these sides are very reddish, which means if you are trying to interpret it in the language of flood, you realize all these are high risk flood areas, and whereas this yellow sides are moderate to low risk, and then the green sides are probably the highlands, which are um, low, very very low risk flood areas. So this is how to picture this in 3D. It's very interactive. You can save this and use it for further analysis, or you can zoom in further and then do whatever you want. All right, so let's go back to our ArcMap. So this is what we have here, and that is what we have in the arc scene. So there are certain things we need to um, get when we are doing the flood risk analysis. So having your digital elevation model, you need to get other information like the slope. You need to get something like the aspect. You can also generate certain things like the contours and a lot. So let's get started on how to derive certain um, information from the DEM. So to do that, we need to open our Arc toolbox. All right, so we need to open our Arc toolbox. Then we can perform certain analysis. So before we do that, one may ask, what is the aspect, what is the slope, and what is the hill shade, what is the contour, and what have you. So these are just some analysis that will help you perform the analysis, the flood risk analysis. So to do that, we need to go to our spatial analyst tool. Then we come down to surface. Yeah, so at the surface section, you're going to see something like the aspect, contours, contour list, curvature, hill shade, slope, watershed, visibility, and what have you. So the contour, so let's start with the aspect. So the aspect in the context of GIS or spatial analysis or any flood and related analysis, it is just a representation of the compass direction that the slope or terrain faces. So it's just the compass direction that your DEM or your digital elevation model or your slope or the topography of your land um, is facing. So this aspect is a very fundamental component of terrain analysis, and is commonly used in the field of geography, geology, hydrology, and environmental um, analysis or environmental science. So, as you can tell, we have certain compass directions like zero. It actually ranges from 0 to 360 degrees, and representing the 360 degrees of the compass. So each degree corresponds to a specific direction. So you need to keep that in mind. Each degree corresponds with each direction. So sometimes one may ask, what does this mean? So in the aspect of maps, these are valuable informations that is used in the field of agriculture. It helps to understand how sunlight exposure varies across a landscape. So we can open this scene, for instance, like this. So let's zoom out a little. Let's zoom out a little. Okay, we have it here. All right. So what aspect is trying to tell you is the direction a slope or the elevation is facing. So in terms of agriculture, it will help you if this section is facing the sun or not facing the sun. So the angle, the compass direction of this slope is very important, and also this side. So let's say you are here, you want to understand if at what angle is this slope is. So when you perform this analysis in ArcMap, you'll be able to know if this area here will receive sunlight. So when you are planting, you'll be able to do that. Or sometimes too, in the case of flood and not agric, you can easily tell where the slope is facing, and to tell you which sites are very dangerous when it comes to flood analysis. So in ArcMap, we usually represent them in colors to beautify the situation, and you are going to perform that in um, ArcMap. So we come here, we open our aspect. So we can input raster image is the digital elevation model, so we can just drag it inside. Okay, so you can change the name if you want. So I'll just maintain this and I'll run it. Okay, so we have um the results for the aspect map. So as you can see here, we have different colors, and it tells you which how each section is facing, how each slope or how each elevation is facing, where each slope is facing. So we have the flat surface, we have the northern section. So this northern section is facing sun. We have the northeastern section. So when you look at your map, you see the brown ones are the northeastern section. So you can use this to perform your analysis. So sometimes the red or warm colors, this colors usually represent south facing slope. It depends on the analysis you are trying to perform. Yeah, so the most important thing is to understand each of these compass directions relating to the digital elevation model, so you can perform the analysis. So you can perform the analysis. So the next thing we need to arrive is um, the slope. So we need to also check for the slope using the DAM. So here we move our input raster, then just click on OK. Okay, so we have it here. Okay, so one may also want to know what a slope analysis is about. So the slope analysis also refers to the steepness or the gradient of the terrain in the geographic area. So we just want to see how steep the slope is, how steep or gentle our elevation is, or how steep um, or how steep how steep or gentle our digital elevation model is, so how steep our topography is. So it provides a valuable information about the slope of the land at different locations. So at different locations you could tell how steep this slope is. So you could see from the results here, the green ones have quite a gentle slope. So usually um, 0 to 1, and then the red ones they have high values. So you could see these sites are usually high areas. So we can compare that to our digital elevation model here. So you could see that sites are mountainous regions, and then from our model here you could see different results. So this is one thing about the slope using the DAM. Then there are other functions like the hill shade, the contours, the watershed. So depending on the analysis you want to do, you try each of them. So today we are just going to focus on the aspect and the slope. Okay, so we have our aspect map, we have our slope information, we have our digital elevation, and then we have our classification model. So now we want to perform this analysis. So you can do it just the aspect map, make a map using this aspect, but we want to reclassify them based on these values we have here. So we have 1, 2, 3, 4 values here. We want to reclassify them into these. So to do that, we need to open our properties and we come to our symbology, then classes, for apply. So as you can see, the classes have changed for the aspect. Then we can change our color because that's not what we want. So let's take a cool color. Okay, then we can also do that for the slope properties, classes. We just need 4 classes. Apply and OK. So as you can see, we just have 4 classes. All right. So the next thing we want to do is to reclassify this information. So to do that, we need to, you can just come to the search and just type reclassify. Then we search for it. So reclassify spatial analyst. Then we can input our raster. So let's start with our slope. So you could see these were the original values, but I want to reclassify them into just four classes. Then the method, each of this method here has their own meaning, so you need to find what you are looking for so that it doesn't affect or distort your data. So since we are just doing it four classes, we'll just go with the quantile. Then okay, then we can change missing values to no data. Then we'll click on OK. So it's going to run it for us. So as you can see, it has done the reclassification. So one may also ask, what is the reclassification in ArcMap? So in ArcMap, reclassification is just the process of changing the values or of the cells or the pixels within a raster data based on a defined set of rules. So based on the information you want to gain, you try to do that reclassification. Yeah, so that is basically um, what reclassification about. So it's often used to reassign or group values into different um, categories or classes, which can be very useful, especially when you're performing any spatial analysis. So now we've classified our slope information. So now we can see that the four having this color will now be our low, high slope, high slope. So that is the essence of the reclassification. So based on the information you want, you can do it. So the highest number here becomes our the higher slope, and then the single value we have here becomes our um, lower slope. So we have our higher slope, lower slope, and then in between we have the moderate slopes. But for the previous ones, the green was our higher slope. So depending on the first value was a higher slope. Yeah. Then the next thing we want to do is to reclassify our aspect information. So we just need to come to our search, reclassify, and aspect. So the same procedure, we just need four values, four classes. Then choose the quantile as my method, and you can change the name if you wish, and okay. And it's going to do the reclassification for me. And the last one we want to reclassify is the supervised classification we have here. So, okay, so now we want to reclassify our classification. So we just need to open our classification, then input our data. So it's already in four classes, so there's no need changing anything. Just need to click on OK. All right, so here the reclassification, you want to assign new values, so you want to know what each values really mean. So if there's a need you want to change any information, you could do that. So for the old values, probably our first one was built up area, so you want to still maintain it, and if the two was vegetation, you want to still maintain it as two, you could do that. Three water bodies, you want to maintain it, you could maintain it. And for bare land, you want to maintain it, you could maintain it. And you click on OK. If there's a need, you could change it based on the information you are after. All right. So the informations we have here. So our one becomes our settlement, and two built up area. Sorry, two vegetation, the green part, the brown bare lands, and then sorry, the brown here would be water body. So you could change the color if you want or if you wish. Then yeah. So once we're done with this, we want to overlay this three information, the reclassification of our classification, the reclassification of our aspect, and then the reclassification of our slope. So to do that, we can type just overlay. So overlay, this is our overlay tool. You are going to open it. Sorry, not this overlay. So we need to type in weighted overlay. Yeah, so we have it here. So weighted overlay. Then we open it. So we are going to overlay this three information. So you can just input your data by using the addition sign here. Then input raster reclassification. So as you can see, these are the data we need. So the reclassification, we click on OK and it's going to appear. Then the next one is our aspect. Click on OK, and then the last one will be our reclassification of the slope. All right, so we have gotten to the aspects of the weighted overlay. So now we have three information in this ArcMap, and we want to add weights to each of the following classes of data we have. So the reason is you want to know and perform the flood risk analysis here. So you could see the influence here is out of 100%, and you would like to spread out this 100% across all board. So it's like putting one thing on the other. So how would one affect the other? That is basically what we are trying to achieve here. So you can see from the information we have here, we have the weighted class of our aspect map. We have the weighted class of our slope, and then the classification. So we are trying to overlay these informations on the other to see the risk involved. So that is basically what we are trying to achieve here. So we want to also know that the spatial overlay to this analysis is very important because you want to combine layers in order to create a composite map. So just one map. So instead of having this separate, this separate, this separate, you want to have just a composite um, map. So let's start by assigning our weight. So we have our reclassification information. So what is the risk, the high risk involved here? So you should know that for the slope, the aspects, and the reclassification, which one would you want to assign a bigger weight, or which one is very very important, or which one is at high risk? So basically, you can make this 45%. Then you share the rate the weight amongst the rest 35%, then we could give this 25%. However, you should know that when you are doing it, it should sum up as 100. And so if it doesn't sum up as 100, you would see this red sign over here must be equal to 100. So we need to change our assign weights to make sure the values here are okay. So probably here could be 20. So we are assigning our classification, that is our land, vegetation, bare land, and water body, at a very, we are giving it a higher weight, and then we have our aspect, the shade, the compass direction of the landscape, and then the slope. Or better still, we could make here 20 and then make our slope 35. Then from there you just need to click on OK. So you see the sum of influence should be 100. Then click on OK. Alright, so we have assigned weights to this information here, so we can check the rest. So let's just turn all layers off, then just check this one. So this is our final analysis. We have overlaid this three information in order to achieve just this composite map. So the interpretation will all depend on you. So from here you could see the red sections, -1, they are high risk areas, and then the green ones are the moderate ones based on the overlay analysis we have here. So you need to assign and make the analysis very thorough, and then in order to ensure the accuracy of the flood risk analysis. So based on the reclassification, you need to know the specifics of what you are doing before you perform the weighted analysis. So back then we go to our digital elevation model, the 3D format. So you can compare this analysis to the flood rates analysis we have here. Then you can create a beautiful map out of this by switching to the map layout, and then creating a very nice map. So this is it about flood risk analysis. So there are lots of tools you can use. The watershed, you want to find the hillshade, the curvature of the landscape, the contours without barriers. All these analysis or surface analysis you can perform using your digital elevation model. And to also represent it in a 3D format, you need to open your ArcScene in order to get a very 3D dimension like this, and you can play around this in order to get a very beautiful work. All right guys, so thank you so much for watching this video. I hope this video helps you a lot in the analysis you are trying to perform. So catch you in my next video, and make sure you subscribe to the channel. If not subscribed, make sure you subscribe. Share this video if you find it very useful. Make sure you comment your thoughts. All ideas are welcome. Until then, stay safe and bye.